In this lesson, we're going to use our techniques for solving systems as tools to solve word problems. So we need to remember that there are three techniques that we've studied so far. The first one is graphing. Now, although this technique is very, very visual, it is probably not going to be very useful in our problems. The second technique was substitution. And in this technique, it is very, very useful if one of the two equations is either in the form x equals or y equals, or it would be pretty easy to get it, one of them, in those forms. The third technique we looked at was called addition. And in addition, we need the two equations set up in parallel formats. In other words, the x's to get lined up, the y's, the equal signs, the constants, and we have opposites in the coefficients of either x or y. So with our systems, not only are we going to have to be able to solve them, but we have to actually choose which of the techniques would be most effective for a particular system. All right, let's look at some problems. The first problems that we're going to practice, we are not going to solve. We're just going to practice in the translation. Now, when you're solving systems, it gets to be a little bit easier because we always let x represent one of the unknowns and y represent the other unknown, and you get to choose. Sometimes the problem itself will tell you what to choose. This one says a smaller number and a larger number add up to 15. That will be one equation. And have a difference of 1. Now, the subject of this sentence goes with this expression also. All right. Now, right now, the author of the problem is helping us out. He said, let x be the larger number. So this will be larger number. And let y be the smaller number. It might seem like just busy work, but I do not think it is. Identifying what your variables stand for and taking the time to write that down can help you throughout the problem. All right, what does it say? A smaller number and a larger number add up to 15. A smaller number and a larger number add up to, that's why I put the plus, or equal 15. There's one of my two equations. The other one, and have a difference of 1. Okay, so I go back and say a smaller number and a larger number have a difference of 1. It has to be the larger minus the smaller equals 1. Because we identified one as large and one as small, it has to be the larger minus the smaller equals if this is a positive number. So I just need to find out which of these matches the system I came up with. Well, it is 2x. No, I did not have a 2x. 2x plus 2y. No, I did not have that. X plus y plus 15 equals 0. No, I didn't have that. X plus y equals 15. Well, I had y plus x. The commutative property of addition says those are equivalent. X minus y is 1. X minus y is 1. My choice is this one. All right, and I'm not solving that. Second problem, practicing more with the setting up, still I'm not solving. It says, Kiko has $5,800, which she has invested into two accounts. The larger account is 600 greater than the small account. Let x be the amount of money in the larger account, so x is larger amount, and y be the smaller amount. Now, I'm just working on my systems. I'm ignoring these choices for right now. She has a total of $5,800. Well, total. That means that x plus y is 5,800. Total means to add them up. Next, the larger account, write down the larger account, x is, that's your verb, equal sign, 600 greater than 600 plus the smaller, and the smaller was y. I read and I write exactly in the order, and the verb is your equal sign. All right, x plus y equals 5,800. I see it right there. Do I see the other one? X equals 600 plus y, x equals y plus 600. But remember that the commutative property says those two are the same. You look at all the others and they are different in one way or another. This is our choice. All right, I think we're going to look at some now where we're actually going to first translate, decide what technique to use, and then solve. All right, the first one. Two numbers total 72 and have a difference of 8. Find the two numbers. Now it doesn't tell us what to be what, but I'm going to say x is the larger and y is the smaller. Two numbers have a total of 72. That means they add up to be 72. So my first equation is x plus y is 72. They have a difference of 8. That means that the larger minus the smaller is 8. One translation for each one of the independent thoughts up here. All right, now I have to decide what technique to use. I believe that because these are nicely lined up, I have opposite coefficients with the y's, I am definitely going to use the addition method. So when I add them, x plus x gives me 2x. The y's cancel, equals 80. Divide by 2, and x is 40. I have one of the two unknowns. Now, find y. Well, let's see. I have either one of them. I'll pick the first one. X plus y is 72. You pick either equation, plug in what you know. 40 plus y is 72. Subtract 40 from both sides, and y is 32. 40 is x, it's the larger. 32 is y, that's the smaller. That will help me make sure that I put the answers in the right spot. So I need 40 there and 32 there. Okay? Let's go to another one. The first number plus twice the second number is 22. Twice the first number plus the second totals 23. Find the numbers. All right, they don't mention large and small. So I'll just say x is the first number and y is the second number. So it's time to translate. The first number, well, that's x, plus sign, twice the second, 2y, is, that's equal sign, 22. First plus twice the second is 22. Next equation, twice the first number, okay, that will be 2x, plus the second, totals or equals 23. All right, it's time now, I've got my system. It's time to decide if I want to use addition or if I want to use substitution. This system is not ready for either method yet. So I think I would like to get it ready for substitution by solving the first equation for that x. So I have x plus 2y is 22. Subtract 2y from both sides, and I get x is negative 2y plus 22. All right, new system. The first equation has become x equals negative 2y plus 22, and the second equation is still 2x plus y is 23. It is now ready for substitution as a technique. This is the value for x. I'm going to take it and substitute it into the other equation in the place of x. I'm going to have 2 parentheses, negative 2y plus 22 plus y equals 23. Solving this, I'll use the distributive property. Negative 4y plus 44 plus y is 23. Combining those, I have negative 3y, because that was an implied positive 1, plus 44 is equal to 23. Subtract 44 from both sides. I have negative 3y is equal to negative 21. Divide by negative 3, and we get y is 7. Okay. Now, find x. When I'm using substitution, I personally always go grab the equation that has a circled side. So x is equal to negative 2y plus 22. Substitute. X is equal to negative 2 times 7 plus 22. X is equal to negative 14 plus 22. X is equal to 8. So I have y is 7 and x is 8. Back to the question. The smaller number must be the 7 and the larger number is the 8. Okay. Let's look at the next one. It says, Jen Butler has been pricing Speed Pass train fares for a group trip to New York. 3 adults and 4 children must pay $82. 2 adults and 3 children must pay $58. Find the price of an adult ticket and the price of a child's ticket. So I'm going to say X is price of adult and Y is the price of a child. Now, if you were figuring out, if you had your family, you would take the price of an adult ticket times the number of adults, the price of a child ticket times the number of children, add it up, and that would be your total. Well, we have some unknowns. So in our first scenario, we have 3 adults and 4 children pay $82. All right, 3 adult prices, 3x, plus 4 children, that's 4 child prices, 4y, has to add up to be 82. In the next scenario, 2 adults and 3 children pay $58. So 2 adults and 3 children pay 58. Now, in this system, it is obviously not ready for substitution, nor would it be easy to get ready for substitution. It's going to take some work, but I'm going to get it ready for the addition method. I can either get both of the x's into 6's, one positive, one negative, that's the least common multiple, or I can get the coefficients of the y's to turn into 12s, one positive and one negative? I think I will target the x's because that's a smaller number. That's my motivation. So, what would it take to turn 3x into 6? It would take me multiplying by a 2. What would it take to turn 2x into 6x? It would take a 3. One of those needs to be negative. It doesn't matter which one. I choose the bottom one, just for no particular reason. Now, 2 times 3x gives me 6x. 2 times 4y is 8y. Equal sign, 2 times 82 is 164. Be sure you multiply every term by that number you've chosen. Next one, negative 3 times 2x is negative 6x. Negative 3 times 3y is negative 9y. Equal sign. Negative 3 times 58 is negative 174. All right, now it's ready for addition because I have opposites in the x's. Those will cancel. I end up with negative implied 1y is equal to negative 10. Divide by that negative 1, and y is 10. That means that the price of a child's ticket is $10. Now, find x. You get to pick any equation. I think I'll pick this one just because the numbers are smaller. I have 2x plus 3y is 58. If you picked one of the other equations, you will get the same answer. So I have 2x plus 3 times 10 is 58. 2x plus 30 is 58. Subtract 30. I have 2x is 28. Divide by 2, and x is 14. So, the price of an adult ticket was $14. The price of a child's ticket was $10. Those are your answers. There's a good bit of work involved in these problems. Okay? And by the way, I should have said as I started that problem, I call this kind of problem a mixture problem because you're mixing up different valued items. In this case, adult and children's tickets. This is called a mixture problem. The next one we have, it's another mixture problem. Kevin and Randy Muse have a jar containing 62 coins, all of which are either quarters or nickels. The total value of the coins in the jar is $6.50. How many of each type of coin do they have? Now, I know you wouldn't really do algebra to solve this. You would just count the coins and sort them and so on. But this teaches us a method, again, for working with mixture problem. All right, how many of each type do they have? I'm going to let x be the number of quarters. And I'm going to let y be the number of nickels. Now, in some problems, you have to be told about the values of things, or you have to search for the values of things. When we're talking about our money system, you already know that a quarter is worth 25 cents. And you know that a nickel is worth 5 cents. Okay, so they assume that that is common knowledge. All right, let's see. If I have two unknowns, I have to have two equations to have a system. First statement, Kevin and Randy have a jar containing 62 coins. Now, I don't know how many of each, but I know that the quarters plus the nickels add up to 62 coins. That's not money, that's just coins. Now, value. Every quarter is worth 25 cents. Every nickel is worth 5 cents. Now, at this point in the problem, you have to make a decision. Money can be written in cent notation, or it can be written in dollar notation. A nickel is 5 cents, or it is 0.05 in dollar notation. Now, the dollar notation is what you're given here. The only issue is it's decimals. If you don't want decimals, then that $6.50, which is in dollar notation, is 650 cents. If you put these numbers into the problem, it's fine. You're probably going to end up moving the decimal points as you do most equations with decimals. Otherwise, just stick with the cents. I think it'll be easier. We have 25 cents for every quarter. So 25x gives us the money in quarters. Plus, we have 5 cents for every nickel. So 5 times y is the money in nickels. And it adds up to be 650 in cents. Okay, let me just say one more time that if you had chosen 0.25x plus 0.05y equals $6.50, that might look better, but you're going to end up moving this decimal 2, this one 2, this one 2, and you're back to this equation anyway. So that's why I skipped that step. All right, I think I would like to do substitution, and I think it would be pretty easy to take this equation, which is x plus y is 62, and subtract y from both sides, and x is equal to negative y plus 62. So, new system. I now have x equals negative y plus 62. And I have 25x plus 5y is 650. I'm using substitution. This is an expression for x. I'm going to take it and plug it in the place of x. That's going to give me, when I substitute, I'm going to have 25 parentheses negative y plus 62 plus 5y is 650. Use the distributive property. That's negative 25y plus, if you multiply those, you get 1,550 plus the 5y is 650. Combine your like terms. You'll end up with negative 20y plus 1550 is 650. Subtract 1550 from both sides. I have negative 20y is equal to, that'll give me negative 900. Divide both sides by negative 20, and y is 45. We just found out if y is 45, that we have 45 nickels. Whoops. Now let's find the number of quarters. I take the circled equation, which is x equals negative y plus 62, plug in that value, x is equal to negative 45 plus 62, so x is equal to 17. That's the number of quarters. Okay, so answer the questions accordingly. Those were both mixture problems. Our last two problems are also mixture problems, but they're what I call liquid mixture problems. These are useful problems if you, say, are a chemist pharmacy tech, many different times you're going to have different concentrations of some liquid mixtures, and you're going to need to mix some things together to get exactly what you want. Now, I choose in these problems to draw a little picture. This one says Doreen Schmidt is a chemist. She needs to prepare 24 ounces of a 7% hydrochloric acid solution. That's what she wants. That's her goal. Find the amount of a 12% solution and the amount of a 6% solution she should mix together to get this solution. Okay, she wants a 7% hydrochloric acid solution. She has a 12%, which is stronger. She has a 6%, which is weaker. How much of each of these should she mix up to get this correct concentration? And she wants to have exactly 24 ounces. Okay, algebra will do this for us. Here's a picture of what's going on. We have, and please forgive my poor drawing, but we have beakers of fluid that we're going to mix up to get what we want. And what we want is a 7% solution, and we want 24 ounces. We have a 12% and we have a 6%. How much of each? Well, that's a question. That means we don't know. So I'm going to say that we're going to add X ounces of the 12 and Y ounces of the 6. Every time I do a liquid mixture problem, I draw this similar picture to help me figure out what's going on. Now, writing the equations. One of the equations is just about ounces. Well, the ounces are the quantities marked on the outside. The first equation would be that X ounces plus Y ounces equals 24 ounces. The second equation is going to be about the acid in the solution. 12% of this one, so watch what I write. 12% of X plus 6% of Y equals 7% of 24. Because the acid in this one plus the acid in this one adds up to be the acid in this one. Now, how do I write this algebraically? Because I have words in here and I have percent symbols. This one would be 0.12x plus this would be 0.06y equals 0.07 times 24. Remember that a percent is hundredths, so that's 12 hundredths, that's 6 hundredths, that's 7 hundredths, switching them into decimal formation. But I will then use my shortcut, which says I can move that 2 places, that 2 places, that 2 places, which means that I'm back to 12x plus 6y is equal to 7 times 24. In the future problems, I am going to skip this step. I'm going to skip this step, and I am simply going to say 12x plus 6y equals 7 times 24. This is why I'm allowed to do it. They are actually decimals, but I move all the decimals and then they're back to looking like whole values. All right, so just for cleaning up my page, I have x plus y is 24, which is the ounces, and I have 12x plus 6y is 7 times 24. And by the way, 7 times 24 is 168. All right, how am I going to solve this system now that I have it set up? Well, I think you could do addition, say multiply the top equation by -6, and then the y's would drop out. But I think I'm going to use substitution. I choose, and it's just a choice, I'm going to solve for x. So x plus y is 24, subtract y, x is equal to negative y plus 24. All right, new system. I have x equals negative y plus 24, and I have 12x plus 6y is 168. All right, since I'm using substitution, this is a value for x. I'm going to plug it in. That will give me 12 times negative y plus 24 plus 6y is equal to 168. Distributive property, that's going to be negative 12y plus 288 plus 6y is 168. Combine your like terms, your y terms. Negative 12 and positive 6 gives me negative 6y plus 288 is equal to 168. Subtract 288 from both sides, and negative 6y is equal to negative 120. Divide by negative 6, and y is 20. All right, y is 20. If I go all the way back up here, this is 20 ounces because it was y. That's the 6%. Now, find x. The circled equation was x is equal to negative y plus 24. Put in the y value. X is equal to negative 20 plus 24. X is equal to 4. So I will need 4 ounces of this. You want to make sure that you answer the questions appropriately. How many ounces of the 12%? The 12%, that was 4 ounces. How many ounces of the 6%? That was y. That was 20 ounces. Okay, let's see if we can maybe move through another liquid mixture problem with more understanding and maybe a little bit faster. All right. This is about Gabe. Gabe Amodio, a nuclear physicist, needs 60 liters of a 40% acid solution. He currently has a 30% solution and a 60% solution. How many liters does he need to make the 60 liters of a 40% acid solution? All right, so he's got to mix up different concentrations. So here go my beakers, which of course will not look really like beakers. All right, he needs 60 liters, not ounces this time, but liters, of a 40% acid solution. He has a 30% solution and a 60% solution. So he has one that is weaker than the 40 that he needs and one that is stronger. How much of each does he need? Well, how much is a question, so those are our unknowns. To write our system, one of our equations will be about the liters. X plus y is 60. The other is about the actual acid in there. So we talked about the shortcut last time. We're going to say 30x plus 60y is 40 times 60. And unfortunately, I see a lot of people that forget to multiply this concentration times this volume. But don't forget that. So that will be 2400. I choose substitution again. So I think I will, again, solve for that x. So I have x plus y is 60. I'm going to subtract y from both sides, and x is negative y plus 60. I have a new system which will be ready for substitution. I have x equals negative y plus 60, and I have 30x plus 60y is 2400. All right, there's my value for x. I'm going to substitute it. So I have 30 parentheses, negative y plus 60 plus 60y is 2400. Distributive property, negative 30y plus 1800 plus 60y is 2400. Combine your y's, negative 30 and positive 60 gives me 30y plus 1800 is equal to 2400. Subtract the 1800 from both sides. I have 30y is equal to 600. Divide by 30, and y is 20. If I go back up to my problem, I will see that I need 20 liters of this 60% solution. So this one is going to be the 20. Now find x, grabbing the circled equation. X is equal to negative y plus 60. X is equal to negative 20 plus 60. X is equal to 40. X represents the number of liters of the 60% of the 30% solution. So I need 40 liters of the 30 and I need 20 liters of the 60. Okay, so yes, liquid mixture problems can be kind of long and complicated. I think it's very, very helpful to start out with this little drawing. Kind of keeps it all in perspective. All right, when you're doing your problems, you do not necessarily have to choose the same method I did. If I chose substitution, you might choose addition, and that would be absolutely fine.